making it.
Hello.
How's it going?
Great. Another day of continuous Zoom meetings. Lovely. Often in parallel. It turns out that I can run WebEx on one machine and Zoom on the other, and then I can have two going at once.
Maybe get them to talk to each other.
Sometimes they can hear each other.
You must have some super powerful internet to handle that.
If I'm sitting in my dining room, it's pretty good. I never have a dropout, and room for whatever reason, even though I have satellite stations and everything, every hour or so I will just lose. Then it will come back.
Did you rehearse that? Because your internet dropped out halfway through you saying it.
Right.
No, well, I'm not in the back room, so it shouldn't have.
And yet, you should watch this one back. Might be quite funny.
Well, it didn't drop out for 2 to 5 minutes. It dropped out for maybe 10 seconds, right?
Yeah, 2, maybe, or 3.
Yeah. No, it's insidious when it's in the back room. It's very strange. It's probably interference from our neighbors. But anyway, questions?
It's what, L-band or C-band?
Hi.
Let's see that.
I guess I have the question of the morning that I asked. I asked you my question and I get some answers, but I tried them and it didn't work. So I don't know what I'm doing wrong.
So this morning you were asking about setting up your NetRC file, is that right?
Exactly, yeah.
Okay, so let's see. The NetRC file has a particular structure. You have it now, I guess, and it has that first line which says machine and then the name of the machine. And the second line that says login and then your username. And then the third line says password, and then it has the same password as well as the same username that you used to create the Earth data account, not the UNAV. Right, you've got 2 logins, one for the NAVCO OpenSAR lab and the
So may I ask you where you are reading these instructions from? Because I have 2 or 3 in front of me and I couldn't work out with any of them. So I'm wondering if mine is different from yours.
problem is we can't really display our NetRC files.
I have a fake one. I have a fake NetRC file. I have figured this out. Well, I say figured it out. I have a potential solution. Let me. Okay, so I'm going to set up a terminal. And I haven't moved directory. I'm in my home directory. It's home Jovian. I type ls-a, and I get all these hidden files. I have this thing that I've called netrc fake, which has all the right structure, but isn't real. I type cat.netrc fake. That's the structure that the file should have. Right, so there can be like no gap here. That would also be fine.
Yeah, so when I write cat.netrc, then I can see my username and my password here. So
right, and it's on 3 lines.
2 lines. Yeah, 3 lines.
So some people say it has a problem.
Because I mean, mine is just 2 lines. So it says machine URS fdata.nasa.gov, and then login and password. And then again, this one is repeated.
Right. So some people say it's important that they all be on separate lines, these three things. If you don't know how to do that,
Thank you.
You would open it with Emacs, say, and
So what did you write? Emacs, what?
Emacs, and then you would type .NET-RC.
Okay. Should I have fake in front of it as well?
This is my version that I've written so that you don't see my
Sorry,
password.
yeah. Sorry. Okay, yeah.
Yeah. All right. So
There was also something on the Slack from somebody about certain special characters have been causing trouble. I think like the $sign maybe.
yeah, that was definitely the problem for somebody, for Alex, I think.
I mean, I have just @, so I guess.
You don't need any special characters in your password. You need one number and one capital letter. So one thing you might try would be to.
Okay, I will do that.
So yeah, so my password here, which is not my password, has a 0 and a capital D in it. And that's that. So those 3 lines, you can use this to put in the return so that everything appears on its own line. And then to exit, you do Control-X, Control-S, and it saves the file. Control-X, Control-C, and it exits. Chat.
Okay. So should I Control-X? Should I do Control-X?
Control-X and then S. Control-S.
Control-S. Okay, and then.
And then Control-X, Control-C.
Okay, yeah. So I did it and I'm exactly right here that you are right now.
All right, so try it now and see if it works, firstly. And then if it doesn't work, we can try some more things.
Well, did you change anything?
You put the lines in, the returns in, right?
So by trying, you mean to write
Just
down again?
Try the thing that didn't work
Uh-huh.
and see if it works now.
Okay, I tried that one. Thank you.
I do it now. We're all here.
Okay, thank you. Maybe first I should change my password in ASF because it has @ in it. And then I should get back to see if it works. Yeah.
You
Yeah,
have
if
to
you
edit the
change
file
your
again.
password in the .NET-RC file, then you'll have to change it at ASF.
Yeah.
Okay, well, we'll be here. So get on with it and report
Thank
how
you.
you do.
Thank you.
Hey Gareth, this is Amit. I have a question like the sheet that you showed, like the notebook, you had 2 different angles. One was the look angle and the other was the sum angle. Like I was wondering if you could like tell me which angles you were talking about in that notebook.
Yeah. Do I have a good figure for this? This isn't exactly right, but for what I was talking about, but I get you the idea. Maybe. Okay. Hang on a second. Where's my controls gone? All right. So there's 2 things to consider, right? When a satellite's in flight. One is that the radar is mounted to the right-hand side of the satellite, and as it's flying along, so it's flying along in its azimuth direction or flight direction, which is shown by V here, and the radar is pointing off to the right. Right. So that's one of the angles is the angle that is related to this pointing.
Okay.
It's called the azimuth angle in, I think, in the file that ICE produces, which is kind of confusing because azimuth is also used to refer to the flight direction. So I use the term pointing direction. And so that's one of the angles. And the other one is the incidence angle, which is the angle that the radar makes with the ground when it's incident on the ground. So one of those angles is going to be like a 3-digit number usually, and that's the one that's related to pointing. And the other one is an angle between 0 and 90, usually somewhere between, for tops, it's between 30 and 45 degrees-ish.
Okay.
And that is this angle, the incidence angle.
Okay. So is this slide available somewhere, or should I take
I'm
it?
not sharing it because they changed the terminology in the notebook. The
Okay.
angle, I'd have to go and rename. I think I called this data in the notebook, and the other one's phi in the notebook. I know they're not the same in this, so
Okay. So
let me dig around in my file somewhere and see if I have a version which is actually correct for ICE.
okay.
But that's the general idea. Those are what the two angles are. One is the horizontal pointing angle, and one is the vertical pointing angle.
Okay. Okay. That makes sense now. That's a little clear. I have like a general question on like a big application for it. So my background is civil engineering, and and my interest is looking at pavements, like seasonal change in the pavement with respect to time. And the main issue is the resolution. So the freely available is just Sentinel, and most of the pavements that I look at probably be 20 to 30 feet wide. And the resolution is what we have here, what we get as a large, significantly larger than that. Is it possible to do that, or is it possible to use Sentinel data to look at those things?
Someone else want to speak? Francis muted.
You're looking for subsidence?
Yes, like change, primarily subsidence for pavements, and probably slope movement and slopes, like not big mountains, but smaller slopes, which is more interest to, like, for example, a highway slope, like whenever you go off ramp or you take a ramp, the slopes like that. So that's my area of interest. And is Sentinel data or upcoming ISCE, is it a good candidate, or is it something that?
Yeah, for pavement, we've had a study a little while ago with the Virginia DOT, and it did turn out that there are limitations to C-band. There's one of them is resolution. The other one is, depending on the quality of the road, is also radar cross-section at C-band. If you have very smooth road surfaces like highways or interstates, in some places, not where I live, they're all shitty. The radar cross-section is very low in C-band, so the coherence is often not that great. So we found that data from Cosmos, SkyMed, TerraSAR, the X-band sensors is more promising because the high resolution and the improved radar cross-section, both for looking at things like pavement deformation, like subsidence and slope motion, but also if you are interested in things like surface roughness or sort of breaking of pavement, there is, it turns out, a decent correlation between the radar cross-section of a road and the International Roughness Index, IRI, parameter for that road. So we found X-band more promising. It doesn't mean that you can't do anything with C-band and L-band. There are certain things that you probably still can do, but not as reliably as with X-band.
Yeah, I read your paper with Virginia DOT, and it was pretty nice. I mean, that was a really great paper. But yeah, so yeah, so it's not just like, let's assume we can get a good backscatter and like a decent amount of coherence. Is like in that resolution, is the deformation like, is it reliable? That's my main question. Like the information that we get from all this processing, will it be reliable for such a small area? Maybe 2 pixels at most.
It depends on how you do the processing.
Okay.
I guess we talked earlier about things like point target processing.
Okay.
You can do that. There's some freeware packages that you can use. There's stamps and there's Fringe that try to do full resolution where possible, full resolution processing. And if you have a deep enough stack, I mean, you have to calculate the deformation magnitude, but also ideally some sort of an accuracy metric. I don't actually know how MinPy does it. Gareth, how do you know? Do they do jackknifing or is there an estimate of accuracy that goes with MinPy?
There is, and I'm not entirely sure how they do it.
So you can do brute force things like propagating coherence information and stuff, which usually leads to you slightly overestimating what the quality of the data is. Packages like Giant, which we don't have in this course anymore, but they basically threw out data. You cycle through, you take a subset of interferograms to calculate the deformation, and you sort of cycle through different subsets and look at the variation of the solution as you use different subsets of interferograms to get an idea of how robust and how accurate or how robust the solution is. And that will tell you, what you can achieve and what the accuracy is you can achieve.
I think the simple answer is if you use full resolution data and you have a deep enough stack, then there's no reason why, if there's coherence, there's no reason why you can't get a result from that. If it's isolated points and there's nothing around it to tie it to, it may be difficult for a narrow road to interpret that effectively. But if you have a long strip of road, it's continuous, you have a lot of points at a full resolution and a deep stack, you should be able to get something from it.
Okay. Yeah. Only one dimension is smaller, but the other dimension is it would definitely be pretty large. Yeah.
Exactly. So you might be able to do some sort of averaging along the road
Okay.
also to improve your performance, depending on the scale of the signal you're looking for.
Okay. Okay. It's technically feasible. That's what I wanted to know.
Yeah, I think tomorrow and the next day you'll see some examples of the stack processing, and maybe it will help build the intuition as to what's possible with those kinds of things.
Okay. Thank you so much. Yeah,
Mm-hmm. But I think Franz is quite right. With ISAR and Sentinel, you'll have a challenge working on that particular problem. You'll need to buy some of the X-band data.
Right. I mean, the new ones are I mean, it's coming pretty affordable. I mean, I hope it's coming. Like I talked with one of the newer ones. They say they're going to give us data for $500 for a scene, and that's more affordable rather than what a SkyMed or TerraSAR. I mean, it's not economically feasible. And I think VDOT did an economic analysis as well. I read that paper from VDOT, and yeah, for civil engineering, that's not, and a lot of DOTs look at that number, whether it's economically feasible or not. So that's why we wanted to stick with the free ones for now. Yeah.
You can judiciously choose the not free data when you do your.
That'll be a good way to go.
Not like us poor scientists. Can't afford to buy data.
All right, Bahara, have you completed the exercise?
I mean, I did it, but it didn't work. I think I'm missing something and I have no idea what I'm doing. So may I just share with you?
Sure.
Yeah, thank you.
Yeah, since you changed your password once, may as well just show us your password and then change it again.
I mean, that's okay. I just want to know how to do it. So right now I have this NetRC here. So does it mean that it should work or should I do something else?
Well, if it has the right format and the right the right password and the right username in it, that would be a good start.
Okay, so sorry, would you please tell me again how I can check my password and username again?
You
I
have
mean,
to log. You
yeah,
logged into the EarthDef website for NASA.
yeah.
Okay, so what I would do then is try to download a file from there using the command line. This is what we've done for other people. So go to one of the notebooks where you have to download something. Maybe the TOPS app notebook.
Sorry. So, I don't know how to see this. You mean something like this? That I have?
I think the one where you do the TOPS app processing. 2 point something. It was yesterday.
Okay.
2.2, I think.
Yeah, if you go 2 tabs to the left, 2 browser tabs to the left.
Go to your file
Yeah.
system.
Right.
Go to
Right.
2.2.
And open that notebook.
And in a minute it will.
Sorry, I don't know why it takes me forever.
It's probably ASF's fault. So scroll down to where it downloads some data. There's a wget command I'm thinking of. We haven't got there yet, I guess. There. Okay, you see, see one of those. Highlight one of those file names. The URL.
You mean
Yeah, the
this
first one. Just highlight the whole thing from HTTPS to the end.
To the end of here?
Just one of them.
Just one of them.
Okay.
One
And
line.
probably without the quotes too.
Okay.
Yeah, like that. So copy that.
Yep.
And then go back to your terminal. Type wget and space, and then paste the file name. What does it say?
Unauthorized.
So click on the link, that one of those links that comes up.
You mean like this one?
I think maybe try it. Does it highlight the whole file name? No, hang on. You have to find one that has the full file name in it. That one got cut off at the end. Is there? Well,
Or getting cut off.
you're getting the last few characters cut off. So, but pick one of them, and then we can copy.
Oh,
and paste
there's
the rest.
if you go 2 or 3 or 4 lines down, I think there's a complete one.
Oh yeah.
Location. It says location colon. Maybe 5 lines from where you are right now. 2, 3.
Like
That
here?
one. Yeah, click on that
Yes,
one. That's
click
a
on that
full URL, including the file name at the end.
If you move your browser up, we can see.
So
quite-
it's
yes.
downloading. It
Yep.
started to download.
So you're
Your login credentials work, but your file is somehow not formatted right.
So, do you know what I should do to solve it?
Well, you should cancel the download unless you want 4 gigabytes of data
Yeah, you're right.
in your computer. Well, maybe we should look at your NetRC file. We can get Melissa to redact it later on.
People
Are
will-
you
or
sure there's no funny characters in it? Because I was able to download like you're doing just now. And again, it was the fact that I had odd
Yeah.
characters in the password.
I mean, I just changed my password, so there's
But did you
just
change your
characters
NetRC
and
file?
numbers, nothing else in it. Sorry?
Did you update your NetRC file?
Yeah.
Does this not have to do with the applications being on the, let's say, a license agreement? I mean, it says authorizer, unauthorized, so perhaps you didn't sign the data.
Maybe you
agreement.
didn't sign a license agreement. If
But
you
usually then it complains when you try and download stuff, and it just started the download. We could try it. Why not?
create a new browser tab or yeah. And I never know what the URL is. Google for Earth data login NASA.
This one?
Yeah.
Sure, that's the one. Okay.
Yeah.
Go to applications.
Go to where it says applications and accepted EULAs.
Oh.
Or yeah, either one is. So there's the ASF data access,
No egress, but
the egress limiter, but
do you have a region of interest selected? Some people said that was also a problem.
Oh, yeah, do you mean that I should define my region of interest here?
Where is that? And does anyone remember in the setup?
Edit profile.
Edit profile.
I think the other one which you could do is go into Vertex and try to download the Sentinel file from the browser. And I think if you don't have something added to your profile, then it would redirect you to accept some.
Choose a physical area instead of other. I don't know where, but no, you've gone
it shouldn't
past
really
it.
matter. This is really only just for tracking, not for. It's not for rejecting people. It's just to make sure we understand what people do with the data, roughly. So you could download. So the username and password seems to be fine. So the NetRC, was that a 2-line NetRC or was it all in 1 line
3 lines.
or 3 lines? When you look at your NetRC file, does it have 3 lines or does it have a single line?
You mean in my terminal?
Yeah, if you do, I'm gonna close my eyes. Do you,
Sorry.
or if you want to unshare or so, whatever you want to do, and just do a less space.netrc or something like that. No,
And
less LESS or more. It's either one of those works. Space.netrc. Oh, that looks.
You have to actually delete those greater than and less than symbols.
Yeah.
Those aren't supposed to be there.
Yeah.
Those aren't part of your username or password.
So what should I do right now?
Use Emacs and delete them. Just the parts around your username and password.
And it seems like you have 3 lines in there also.
Yeah. So
You need one thing on each line.
So
Like if look, we can go back and look at mine again.
okay, yeah.
can do, I think it's is it escape to get out of less? So is it Q? I think it's escape or Q, one of the two.
Three lines, one thing on each line, no greater than or less than symbols because they're not part of my username or my password.
I don't know how to do that. The problem-
Emacs. Remember Emacs?
Emacs.
You can edit things. You can delete. You can move it around. You can type stuff, and then you can delete stuff. So move your mouse or move your cursor around. Delete the things that shouldn't be there. Have one thing on each line and save it. In the meantime, there were some questions on chat. I didn't understand what to do for homeworks today. For the modeling part, find a place affected by a shallow earthquake. Well, there was, you could, if you wanted, and that would be advanced. You could, for example, take the interferogram you made yesterday in the TopSap processing and try and model that one by doing the quadri decomposition and guessing the fault. I said that you could also just try and run the solo optimization. You can loop 100 times through different runs and see if you can find a better penalty than we found in today's exercise amongst the class. If you can find a better model, that might be what you could. That was an option too. And there's actually a third option, which is that I included in the directory, I think, an optimization routine that does solves for dike intrusions. So you could do the quadri decomposition on the ionosphere corrected interferogram of Hawaii and solve for the opening of the dike in Hawaii. Although I don't remember how user friendly that notebook is. Or you could process an interferogram from scratch and do the whole process from end to end if you wanted.
So Emma wanted to show what interferogram she created.
That would be great.
Yeah, would that be okay? I had trouble yesterday with a number of things, so I'm just getting it running, but I'd love to see if I'm wondering if I've done it right or if maybe I've made some mistakes. But if I could share my screen, if that's best, or whatever.
Yeah,
whatever
go for it.
Okay.
We'll stop.
Oh shoot, are you looking at, sorry, I think I gotta stop sharing.
We see TopSap.
A notebook or okay.
A notebook, yes.
Okay, great. So this was so it's a scene in high mountain Asia that is partially glaciated and partially not. And I chose a winter, so it's December 1st to like December 25th to avoid sort of, decorrelation due to surface melt, but I think also there's probably like storms or things like that. Because my correlation image, oh, sorry, I'm just trying to go up. Where is it? I'll just scroll down to the interferogram. Sorry. So it's down here. And it looks like there's a lot of noise over the glaciated terrain, I think. Does that make sense?
Could
Or am I
be.
just thinking about, maybe I've confused myself, but.
I mean, it's an area of steep, rugged terrain.
Yeah. And it's a sort of long time separation between the two scenes. So because my correlation image, I just scrolled by it before, was up here. It didn't look, this is just for a couple bursts, but it seemed like it was sort of localized. It wasn't like a storm that moved, maybe would have moved over the whole area. It was sticking to areas that might be sort of terrain. is that a reasonable interpretation, or do you think maybe I've generated this wrong?
I don't think you've done anything wrong.
Okay.
I think it's challenging to do InSAR in terrain like that.
Yeah.
Yeah, overall, like the pharogram actually looks pretty decent.
It's way better
Look
than
to be
you would
more
have-
like the higher mountains are
Yeah,
decorrelated.
it looked like a
Yeah.
steep ridge or something where it was decorrelated. I don't know.
Okay. Because I noticed that, yeah, some of my like misregistrations were higher than in Haresh's example, but I would figure that that was also maybe terrain, due to the terrain. Okay, thanks. That's really helpful. I just wasn't sure if I was like off track still or not, but
Where is that geographically?
this is in Nepal, so
Okay.
like Central Himalaya.
Yeah, you could swap in the top of phase core.vrt and then you would have the correlation file. I don't know. Not
Oh,
complex data. You'd have to plot that somewhere else
up here where I plot the, okay.
because it's not complex. There may be somewhere else where you can.
Oh, this is the correlate coherence.
Yeah, that's a burst that's the burst coherence or burst
Yeah.
overlap coherence.
Okay, sorry, I would have to look up how to plot the whole one on the fly, but I'll try that on my own.
It'll be, you could probably copy one of the code cells where you're plotting the radar geometry unwrapped into pharogram and swap it in there. So not this, because it's another complex file. Only the wrapped into pharogram is complex. But
Oh, like, wait, this should be not complex, right? Okay,
yeah,
so if I just change this to,
topophase.core.
You would also need to change the band to be band 1. I think it's a single band file.
oh, thanks.
One R.
Thanks.
You might want to change the color scheme as well.
Yeah.
I don't know.
Oh.
You have to change the color limits, I guess.
Yeah, I'll play with it some more. I don't want to take up too much time, but thank you. That's really helpful.
The correlation values are between 0 and 1. So you want to
Yeah, so I need to like do like a vmin, vmax.
Yeah, I think that's one of the input arguments. So if you look at the top of the notebook, I think the functions are made once, and there might be additional input arguments which you could use to specify vmin, vmax.
Okay. I'll look up. Oh. I'll look up top and do that.
Yeah, I think you added it now to the wrong plot. But
I definitely did. Thanks.
Alex also wants to show a little pharogram, please.
Yeah, so here, let me see if I can share this. So I tried to do an interferogram for an area where I wouldn't have expected to see anything, just to see what it would look like. And I get something that looks kind of odd. So this is in the area of the minor deflection in Walker Lane in near the Monte Cristo rupture, but not during the coseismic overlap. And what am I looking at in here? Can you kind of help me out to figure? I was not expecting to really see anything at all, but except for maybe some decorrelation. And the time between these scenes, I think, is just 1 week, and it's in the winter time. And can you give some insight here?
Is it before or after the earthquake?
This is before.
Okay. Well, I don't think you've done anything wrong there either. I think you're looking at atmosphere.
So is it just atmosphere? Is that all it is?
Almost certainly.
So I did the displacements, or where is it? Down way at the bottom. Yeah, so I did the azimuth offsets, but like, what is this? I was surprised to see it kind of in a line. what is happening in this?
I guess that's probably just noise.
It's just noise that happens to be forming a line.
False matches. Yeah.
I see.
Yeah, maybe in a place where there's some, terrain or so, or shapes that replicate each other, so that you get false matches.
So one thing to, when you look at these dense offsets, is to also look at the correlation, which is related to the dense offsets, and potentially apply masking based on those dense offset correlation.
The correlation, okay.
Yeah, so not the coherence or the dot core, but I believe whenever the dense offsets, there is also a metric associated with it in terms of how reliable it is. So you could mask out those which don't have high correlation values, pixel correlation values between the cross correlation windows.
Got it. Well, good. Okay, I was like hoping not to see anything, but I was surprised to see this as it was. So thanks for explaining that.
Yeah, having an interferogram that's completely flat would be a miracle. That I think never happens. You always have, atmospheric wobbling that's in the order of a fringe or two. That's roughly what you see here.
This is our definition of nothing.
Yeah, that's our definition of nothing.
Less than a fringe is effectively nothing.
It's nothing. Okay, well, okay, nothing.
And you see here when you look at this, it seems some of it seems to correlate a little bit with topography. I think there's some patterns that seem to maybe replicate some topography features and other ones don't. This is also typical for atmosphere, that you have a contribution that somewhat scales with topography. I think Haresh talked about this today. And then a feature that's more wobbly, has like cloudish structures, and you have some of those too.
Got it. Well, cool. Thank you.
Jay, you have a question about DM downsampling?
Yes.
Go ahead.
Can you see my screen?
Yes, we can.
Yeah, I remember Haresh mentioned about this line. So I got stuck here. So I copied the line he sent.
Right.
I don't know, should I run this line first before this?
No, you run it second, but you're using it's a different DM file.
Right. So it should be the same.
Yeah, you should use the same DM file.
So can I
Yeah.
just ignore that error message here?
Yeah, you can ignore. So you run the downsample DEM first. It's giving you, it does everything right with the exception of writing out the XML file.
Okay.
And so you can ignore that error and then run this line below second, and it's going to create that XML file.
Which is these.
Yeah, so here you have the XML file.
Let's see.
And now you should be good to go.
Okay. So why I'm doing this?
Oh, this ls command just basically plots the files you have in your folder, just to make sure that you have all the variables that you need and all the files that you need. So this command is the line 28, the one that's labeled 28, has no real consequence for your processing flow. It just makes sure that you have all the necessary files to proceed.
Okay. Actually, my question was why I need downsampling in DM file. I'm just curious, is it for some reason? Or
When you're processing, you have multi-looked. So we're actually geocoding the multi-looked interferogram.
yes,
So we have processed, and I don't know what the default looks are, but I suspect it might be around 110 meters that we might have multi-looked the data to. So whenever you do the geocoding and you would have used your original DM, which has a posting of 30 meter, you would have geocoded it to 30 meters. So by using the downsample.dm, you can actually generate a DM which is closer towards your multi-look resolution and geocoded more representative to the resolution that the data is really at. Often we have seen in the past that if you would have multi-looked the data and then geocoded to 30 meter, it looks very nice when you zoom in, but that is not really the resolution of the data, just the posting at which the data is shown. So it's more of an interpolation result rather than the actual posting at which the data is due to multi-looking.
thank you.
We should probably add that additional line. I don't know what happened there. Was there a change in the ISCE functionality that the XML creation breaks?
Yeah, I think there were some changes compared to last year. So I think we do try to test things, but a lot of it is in the country folder, which has different dependencies. So we might just need to look into it.
I think Haresh said something about the GDAL interface changing. That's why it broke.
Can we save the geocoded interferograms as TIFF files? I mean, in concept, yes. I'm not sure if.
So the interferogram which you have, I think somebody's pointing at it, Garrett. Like indeed, you could do a GDAL translate -OF, so output format, and then do a TIFF, TIFF, I think it is, or we'll double check that, and then you could give the input file and then the output file name .tiff. You might need to specify which band it is specifically, but it is possible. I don't know. It might be demonstrated in the GDAL notebook.
Yeah, I think it is. So just go back and look at that. There'll be a template for it, I'm sure.
Well, I was trying to do what Gareth suggested earlier, which is to run the, I guess going on here in the chat, run some notebooks from today using the TOPS results from yesterday from the coursework, and I ran into some issues, and we've been going back and forth in the chat. If no one else has anything more pressing, this is just for funsies. So.
Let's have it.
You're all up for funsies.
Alrighty. Sorry, what did you say? Age, no data. Yeah. Okay. Yeah. There does appear to be some non-note data cells.
Did
okay.
you actually get to the point where you plot the thing?
Yeah. I did, and it was empty. So I said, well, what's going on? So I'm not doing any of the mask stuff because I can't find the mask files. I think you mentioned in class that that's a problem.
That's something I actually want an answer for. How do you make water masks now that there's a change? That looks like
it's a block.
That totally looks good.
It does. Okay.
It's a bit of a pig of an interferogram to model because you probably need at least 2 faults.
Yeah, sure.
You can model the right-hand side of it probably with one, but the left-hand side is actually quite complicated.
Okay, well, for what's worth, when I do this in another example, it is completely broken, but because I was looking at a test case in the Philippines, and I went cell by cell, and I said, oh man, I'm seeing the same thing as before, and I guess I must not have finished this. So,
well, the reason it says none at the beginning and none at the end, look at your frame, right? The first few pixels are no data, and the last few pixels And maybe even the last line is no data as well.
Yeah. So it doesn't print the full array, it just prints.
Yeah.
Yeah.
You can do like,
Okay.
yeah, you did unique, or you could do nan min or nan max, and it will show you what the non-nan values are like.
Got it. Okay. Well, just kidding. It works. So cool. Thanks.
That's cool.
Yeah.
Did we miss any questions in the chat?
See anything?
Can anyone tell me how to make a water mask? I feel that was a really useful thing that you used to be able to do.
Did that functionality disappear? What happened?
I think the server that served up the dems that were used went away.
Oh.
And my attempts to like reverse engineer a new solution have all failed.
You could look if you go to the ASF GitHub. They just did that for some of the ARIA data using DM access and then basically padding the DM a little bit to create a water mask to mask out for MinPy processing. If you go to the, I think it's ASF admin on GitHub and then somewhere in ARIA tools or so, it's there might be something buried that you can pull.
I'll have a look. Yeah, because it's definitely built into MinPy.
Yeah, and if you can't find it, I can ask either Alex or Joe to send you the right.
For ARIA tools, we pull in the shapefile and we rasterize the shapefile to the same posting as the data.
Could that be adapted to
ICE, you mean?
Yeah.
Yeah, it can always be adapted.
It can be, yes. Has it
Well,
been?
I think the problem
Will
is
it be? No.
but it could be lifted off and done that. And we actually use the national classification database as a refined water mask because it is much more high resolution. You can look at the wetland level, etc. While generally the shape files they might change over time, while the USGS national land change map based from Landsat series that's kind of updated so every so many years. So it actually captures some land use changes. So whenever we're doing InSAR in the delta, etc., we prefer that above, let's say, a coastal shapefile.
Great. So Alex
There's a question about orbit files.
Yeah, and the answer is that they changed it twice in a month. ISA, that link, so it is out of date.
I was trying to download the orbit files manually because I somehow can't seem to get it to do the deload orbits.py not working anymore. So I was just going to download them manually, but I'm not sure how.
Okay, let's look at this. All right, so we are at scihub.copernicus.eu, and they have this thing called the pod hub. This is really you only need to do this for well, you can find all orbit files here, but there are probably better ways for everything other than very recent acquisitions, including there's a server at the ASF that has them. But if you're already up against something that's really new, you go to this pod hub thing and it tells you what the login credentials are. GNSS guest. That's both the username and the password. Login as yourself. You can log in as GNSS guest for this particular purpose, and you can choose the ingestion date, or this, and pick a day, pick today, for example. and we want Sentinel-1. Satellite platform, Sentinel-1 1A, okay, brilliant. And you will get a bunch of download links that you can download the files, and you'll see that there are many of them in this format, this Resorb format, and that's because for whatever reason those preliminary orbits are only valid for a period of a few hours, or they only extend for a period of a few hours, so you have to be careful to download the right one that spans your acquisition date, and they're labeled with the start and end time, all of them, so you can eyeball it. This one goes from 11:58 to 3:16 p.m.
Perfect. Thanks, Gary.
And you can search for precise orbits as well. I didn't mention that. If we went back a bit further in time, if we went back a month, so like July 25th, then we should be able to search for more than just those two. Well, let's go to June. Let's go crazy. And that's long enough ago. You can search for POORB, which is precise orbit, and then there will be basically there might be one file rather than none. Well, anyway.
Cool. Thank you, Gareth.
Yeah. There's a latency of 20 days for the precise orbit files. They're not there immediately. Do you want to show off your ASF orbit facility, France? Or?
No. Thank you for putting me on the spot.
You can W-get them if you know the link.
I actually don't know how to show that off.
I have it. I have a script if anyone wants it, or a script.
It also was rebuilt a few times in the last few weeks or in the last few months because of sudden changes at ISA.
ISA did it twice in a month and didn't really announce it, I recall. Suddenly, just all these things that downloaded orbit broke.